Hey students, Mr. Lupa here talking about multi-step equations and how to solve them and looking at lesson 22. So just a quick overview. We are on lesson 22 in mod 2. You have problems 1 through 5. The instructions we're giving you in class are a little bit different than what it says on your paper. So let me give you an overview before you do anything. We have 1 and 2 are done for you. You don't need to do these. And I'm going to go over how these work. And we're not doing the if-then statements to justify each step. We're not explaining each step. Right now, we're just focused on solving for the variable. Where your work is, that 1 through 5, that's on the next page, right? So the first page, 1 and 2 are done for you. They are examples for you to look at, study, and learn from. Because I know this is new, and there's a lot to it, and it's important, and it's what math is going to look like for the next few years up until you graduate high school. You're going to be dealing with multi-step equations, so we really want to make sure we get this down. So 1, 2, 3, 4, and 5 on the next page are your assignment, and it says for each problem below, explain the steps in finding the value of the variable. This is what we are focused on. The variable is the letter in all of these problems. So we have M is the variable here, V is the variable, Y is the variable, and P, and on number 5 we have K. Right? We use a letter. Usually the most common letter we see is X, but it could be any letter. And we're trying to solve for the variable. The instructions then say to find the value of the variable showing each step. Write if-then statements to justify each step in solving the equation. We're skipping this part. We're not writing if-then statements, okay? But we will show all of our steps in how to solve this. So seeing the steps, what the steps look like is this. So 5x plus 4 equals 19. It's kind of similar to a lot of these problems. This one looks more like number 2 on the previous page. This one looks more like number 1. We want to make sure you guys understand how we solve for the variable. So let's take a look at number 1. We have 5x plus 4 equals 19. Now yesterday, if you were with me, we made up a word problem. We made up an example. So say, for example, John works for 5 hours and he gets paid X amount of dollars per hour. We don't know how much he gets paid per hour. Plus, he already had $4 in his pocket. And by the end of the day, he had $19, right? So when you have a word problem, you could turn it into a math equation. Then you could solve for the variable to find your answer, okay? We do this all the time in our heads. We figure things out with numbers. We don't even think about it. We do these kind of multi-step problems, and a lot of times we can figure it out in our heads. Now, putting it on paper, turning it into an equation and using variables to represent what we're trying to find is the skill we're trying to really learn and hammer home. So let's check it out. I am trying to find X. I'm trying to get X by itself, right? In the end, I'm going to say X equals 3. This is my final answer. And this is all the work in between. And how do I know X is 3? Well, how do I check it? I could go back and plug in 3 for X, right? Because they're equal. If they're equal, I could switch them out and it'll be the same. So if I say 5 times 3 instead of X, right? Because X is 3. 5 times 3 plus 4 equals 19. Well, let's check it. 5 times 3 plus 4. What's 5 times 3? It's 15. Plus 4, that's 19. All right? So we went, and then 19 equals 19. It's a true statement, right? So when you plug in your variable, whatever it equals at the end, you can plug it in and make sure it equals the other side because they have to be equal, right? So all this work when you figure it out, is going to equal the other side. Now let's get into the process. Let's get into the steps for finding the variable. We are trying to get x by itself. So the way I like to think about it is move everything away from the x. You could move it to the other side and keep it even. Yesterday we did some examples with equations where we said, all right, add 4 to this side and add 4 to the other side and see what happens. And when you did that, you saw that they were equal. So if we do something to one side of the equation, we need to do it to the other side, and it'll stay even. It'll stay balanced. It'll stay equal. So what we're doing is we're moving everything away from the x. And I always say move the numbers further away from the x out of there first. So we have a 5 we need to move and the 4, right? Looking over here, we want to get x by itself. So we got to get rid of that 5, got to get rid of that 4. The 4 is further away. We're going to get rid of it first. So if I was to do something to this side of the equation to get the 4 out of there, to make it cancel out, what can I do? I could do the opposite, right? What's the opposite of adding 4? I can subtract 4. So now if I say, so what you guys are going to be doing is deciding what kind of operations you need to do to get the numbers out of there. So if I have 5x plus 4, I'm going to subtract 4 from that side. And now since I did it to that side, I'm going to do it to the other side as well to keep it balanced. All right. If I do it to this side, I need to do it to the other side. So I wrote 5x plus 4 minus 4 equals 19 minus 4. I subtracted 4 from each side. 4 minus 4 is 0. They cancel out. We're going to be doing a lot of steps that make numbers cancel out on one side, and then we do it to the other. So 5x plus 4 minus 4 is this cancels out, becomes 0, right? It shows the work here. So now it's 5x plus 0 equals 15. Because we did 19 minus 4 here, right? So this became that. And this becomes 0. Now we have, what are we left with? We rewrite it as 5x equals 15. Now we need to get the 5 out of here. And we do the opposite to get rid of it. So if it's 5 times x, the opposite of multiplying is dividing. Or you can multiply by the reciprocal. It's the same thing. Because we have 1/5 times 5x. They said 1/5 times 5x to each side to get rid of that 5. See how we went from here to here? That 5 is gone. What made that 5 go away? We multiplied by its reciprocal. Because 5 as a fraction, this is 5 over 1, right? And it's saying 5 times x. Now, how do I get rid of that 5? Well, I could turn it into a 1, right? Because 1 times x is just x. So what it did here is it multiplied by the reciprocal. So if I multiply by 1 over 5, like it did here, let's see what happens. When we multiply fractions, we go straight across. 5 times 1 is 5. 1 times 5 is 5. We have 5 over 5, which isn't just like saying 5 divided by 5, right? Always divide the numerator by the denominator. And 5 divided by 5 is just 1. And what's 1 times x? Well, it's just x, right? So 1x is the same as x. 1 times any number is just that number. We don't write 1x in front because we don't need to. It's kind of like writing 3.0, right? We don't need that part. So when we multiply by the reciprocal, so you take the whole number and put it as a denominator and put 1 as the numerator, so 1/5 times 5x, these will cancel out, okay? These become 1, like we showed here, so that we're left with just an x. And over here, 1/5 times 15 becomes 3. So let me show you guys the work. So 1/5 times 15 over 1. Zoom in a little. All right. I can multiply straight across, or I could cross simplify if I wanted, because I see that 5 goes into 15, right? 5 goes into 5 once, 5 goes into 15 3 times, and we can multiply straight across, or I could not do that and just go straight across. So 1 times 15 is 15. 5 times 1 is 5. What's 15 divided by 5? It's 3. And that's how we got that 3 right here. Okay? And then what I showed you guys in the beginning, I plugged in the 3 for x to check my work. So I said 5 times 3 is 15 plus 4 would be 19. So that would become 19 equals 19. It works. We are correct. Another way you guys could do this. Let me show you one more way. 5x plus 4 equals 19. So this is how I do it. Now, all right, let me get to it. Subtract 4. You could write it vertically instead of across like here. Same thing. If I subtract 4 from 4, it'll become 0, right? It'll get rid of it. Now, if I do it to one side, I need to do it to the other. Okay, you could draw a little line if you want. So if I do it here, I need to subtract 4 over here. That's a 4, not a 9. 19 minus 4 is 15. Okay, so I'm going to rewrite. Next step, I bring down what's left. So the 4 is canceled out. I'm left with 5x equals 19 minus 4, we said, is 15. We're left with 15 over here. So now we have 5x equals 15. What I showed you guys, what we did here is multiplied by the reciprocal. You can do that, or what I prefer to do, and it doesn't matter which way you do it, it's the same thing. If this is multiplying 5 times x, you need to do the opposite to cancel it out. I divide. The opposite of multiplying is dividing. So I divide by 5 to each side to get rid of that 5, right? Because 5 divided by 5 is 1. So I just say, okay, these cancel out. I'm left with x equals 15 divided by 5 is 3. I got my answer. Right? Same answer as here. This is my way of showing it's the same exact work, right? I subtracted 4. That canceled out. 9, that became 15. And then the difference is I divided versus multiplying by the reciprocal. If you guys remember when we work with fractions and you're dividing fractions, you keep it, change it, flip it. That's the same thing, right? So instead of dividing by 5, you could change it to multiplying by 1 over 5. All right? So that's my example for number 1. I know this is new, but check this out. Look at this again, pause it, go back, try. If you want to, try number 2 is a good starting point. It is a negative number though. Just be careful with that. And then number 5, if you see, hey, the variable's on the right side of the equation instead of the left, it doesn't matter, right? Because if you do it to one side, do it to the other. Doesn't matter if you're going to the left or the right. Do what you got to do to get the numbers away from the variable and get the variable by itself. All right, I'm going to have more videos and examples coming up. Good luck.